All right, so before we take the quiz, we'll talk about the journal. It is a new EQ. So you're being asked to calculate the number of protons, neutrons, and electrons in these two ions. Calcium 2 plus and sulfide minus 2. So you want protons, neutrons, and electrons for both. And then also to name it. So we'll start with calcium. It has a +2 charge. It's a positive 2. So to name it, it would be calcium ion. If you don't put the ion with it, it would be incorrect. This was a part that y'all missed and you had to go and watch on YouTube, part 2 of my YouTube yesterday. That's what covered ions, and you will see those on the quiz tomorrow. You're going to have your periodic table out and ready to go tomorrow to be able to take the quiz, and it will be limited time. So element number 20, so that means that it has 20 protons. Because it has a +2 charge, that means that the protons and electrons are no longer equal. It lost 2 protons, so now it has 18 electrons. And then to get its number of neutrons, that's going to be its mass number, which we'll say is 40. I'm going to round its atomic mass to 40. So 40 minus 20 would give me 20 neutrons also. Now, if I do the same thing with my other one, my negative ion, so because it's negative, I change the ending, and it becomes sulfide. You do not have to put ion, but you can. It's element number 16, so that means it has 16 protons. It has a charge, so that means protons and electrons are not equal. Since it has a -2 charge, that means it has 2 more electrons, so it would have 18 electrons. And then neutrons, I'm going to take its atomic mass, 32. So 32 minus atomic number would give me 16 neutrons. And so you will see some of those tomorrow. The practices quiz, your practice had some of those mixed in. And then also there was a practice of just ions that were in your Google Classroom too. All right, before we start with our notes, you're going to take the quiz. So if you'll go into your Google Classroom, under classwork, or you can go to stream. And come down here to quiz. It should be the one at the top. I just turned it on, so it should be accepting responses. It's 10 multiple choice questions, and you have 5 minutes to do it. I'm setting my timer. As I start telling you that your time is running out and you have to submit, you must submit. If you do not submit, you will get a 0. And then you can come during tutorials to requiz. But if you do not get it submitted in time, then that is on you, because I'm going to give you plenty of warning. You have 2 minutes left on your quiz. You have about 40 seconds left, so make sure you get finished up and get it submitted in. About 10 seconds, so last opportunity to get it submitted. Alrighty, submit what you got because I'm going to close it off and it'll be a 0 if you don't have your submitted. There will be no exceptions. All right. Alrighty, so tomorrow you'll have your quiz over subatomic particles and it will include ions. Like I said, you're going to need quick access to a periodic table to help you with that because you're going to be figuring out how many you have of everything. You are able to re-quiz. And you will need to come in for tutorials. But you need to let me know ahead of time that you're coming in for tutorials because it's on Zoom. I don't automatically open those up. So you will need to email me or contact me on SportsU and say, hey, Miss Larry, I'm doing tutorials today. Have them today, tomorrow, and the next day. So tomorrow we'll be doing subatomic particles. For your quiz, you will need a periodic table and same thing. All of the quizzes have a certain time limit. And then what we're learning today, that quiz will be on Friday. All right, so we're moving on with our notes. Rutherford was the scientist that discovered the nucleus. So the protons and neutrons, and Bohr was a scientist that first started talking about different energy with regard to where electrons existed. So kind of that combined, you have what's called the Rutherford-Bohr atomic model. And I believe y'all have done these before where you look at energy levels and you place electrons. So each energy level can only hold a certain number of electrons. Energy level 1 can just hold 2 electrons. Energy level 2 can hold 8. 3 can hold 18. And then you can see it increases with each energy level. So if this is my nucleus, the energy level closest to it would be my energy level 1. And it would be the lowest energy level. And then as I moved out, as my energy level number increased, also the how far I'm out from the nucleus would increase, and also the energy of that energy level. So the higher the energy level, the farther from the nucleus and the higher in energy. And an electron or atoms always want to be at the lowest energy level they can be, or the lowest energy state they can be. So the electrons are always going to come in and fill first energy level first and move up from there. To find out how many electrons each energy level will hold, you can use your little formula 2n squared, where n is your energy level. So if I'm at energy level 4, 4 squared is 16. 16 times 2 gives me my 32. The outermost or the highest energy level is where you have your valence electrons. And those are important because they are the ones involved in the bonding. They'll either be shared or lost or gained when bonds are formed to make compounds. And they do this to increase their stability. So if we look at a couple of these and we draw some Bohr models to kind of refresh your memory, neon 22, that's neon's mass number. That doesn't tell me anything about electrons, so I'd have to refer to the periodic table. So neon is element number 10, which means it has 10 protons, and since this is neutral, it also has 10 electrons, so I need to find a place for 10 electrons. So I'm gonna give myself a little nucleus, and then I'm gonna put my first energy level, and it can only hold 2. So I'm gonna put 2 electrons. Then I'm going to go to my second energy level, which can hold 8 electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. So 8 on that one plus 2 on the first energy level gives me my total of my 10. If you notice, I spaced those electrons out because they are negatively charged, so they would repel each other, just like magnets. If you get them on the same end, they repel each other. So the electrons in real life would get as far apart as possible. Magnesium, this is my atomic number. If it has 2 numbers, the smallest number is going to be my atomic number. So that means I have 12 electrons. So I do the same thing. I'm going to start placing them until I get them all placed. So first energy level, we'll take 2. Second energy level, we'll take 8. 4, 5, 6, 7, 8. And 8 plus 2 gives me 10. So I still need 2 more electrons. So I'd have to go up 1 more energy level and put those 2 in there. All right, I'm going to give you a chance to try this ion right here, this chloride ion. All right, so hopefully if you notice this one, it was an ion with a -1 charge. So instead of having 17 electrons, like a neutral chlorine would have, it has 1 extra. So I need a place for 18 electrons. Okay, Gabriella, I'm going to just stop real quick and address this so that we don't keep on going back and forth. It was a quiz we took today, and my tutorials are Tuesday, Wednesday, and Thursday. I said that yesterday, and I haven't posted in the Google Classroom. So please on Sports U, let me know if it's today that you're coming. If it's not, then you can wait and let me know tomorrow or Thursday. So I need a place for 18 electrons. This is my chloride. And you can put ion, you don't have to. So I'm going to start from the beginning. So there's my 2. 8, my second one. That gets me up to 10. And so I need a place for 8 more, which can go into my next energy level. And then that would give me my 18 electrons that I needed on that particular one. So be sure that you know how to handle the ions, positive ions or negative ions, because you will see those on the quiz tomorrow. All right, the mass of an atom is very, very small. You can see fluorine has an extremely small, to the negative 23rd grams. So it's impractical to deal with grams when you're talking about atoms. They're just too small. So carbon was assigned as a standard by which relative atomic masses would be determined. So a scientist determined the mass of carbon, and everything else is relative to it, whether it's larger than carbon or smaller than carbon, and then how it is within a ratio. So relative atomic masses are given to you in AMU. That's the unit, small letter AMU with no periods when it's being used as a unit. And we'll do some problems with those so you'll see. 1 AMU is exactly 1/12 the mass of a carbon-12 atom. So carbon-12 has a mass of 12 AMU, and everything else is relative to that. We've talked about the fact that 1 proton and neutron have a mass of 1 AMU. And then an electron is much, much smaller. It's like 2/1000 less mass. So basically it's negligible whenever we start talking about the mass of atoms. So atomic mass is the mass of just one atom if you could isolate one atom, which is pretty hard to do. So atomic mass can be also known by the definitions below. Atomic mass is just a general term, and then these 3 are specific types of atomic mass. So for right now, we're just pretty much using atomic mass, but as we move through the year, then we'll start using those more specific terms from time to time. So my first one is molecular mass, which is the mass of one molecule. And a molecule is a covalent compound that's formed by 1 or more nonmetals. And then ionic mass is a mass of 1 ion. We've talked about an ion as an atom that's lost or gained electrons to become more stable. And formula mass is a mass of 1 formula unit. And formula unit is used with ionic compounds, which is when you have a metal and a non-metal combine. And once again, that combination would be done to increase stability. So today we're going to learn how to calculate average atomic mass, which is the mass that you see on the periodic table. And it is a weighted average, so not just a regular average, a weighted average. That means that an isotope that is more prevalent is going to hold more value in this average. So it's a weighted average of the masses of all isotopes of that element. So a weighted average reflects both the mass and the abundance of the isotopes as they occur in nature. And this is the value that we see on the periodic table. Always round to 2 decimal places. So when we're using average atomic mass, tomorrow we'll be pulling numbers off the periodic table, then always round to 2 decimal places. Because sig figs, we can't really follow the sig fig rules here. Our units will be AMU. Small letters, no periods. So to find the average atomic mass, it's the summation. This E means summation of the percent of each isotope times the atomic mass of that isotope divided by 100. Excuse me. So if an element only has 2 isotopes, you're not going to have to do as much math as an element that maybe has 9 or 10. I'll give you all a minute to write down that formula. All right. So let's look at the problem here, and then we'll look at one on your practice. So it says magnesium exists as 3 isotopes. What is the average atomic mass? If you notice, I have my 3 isotopes here. I have the mass numbers, but those are not the numbers I want to use. I want to use the atomic mass for each isotope. I only use the mass numbers if I don't have atomic mass. So if I didn't have these numbers, I would have to use my mass numbers. But if I do have the atomic mass of each isotope, then those are the numbers I want to use. So I'm going to set myself up a little system. So I'm going to take the percent of the first isotope, which is 78.99, and I'm going to multiply it by the mass of that isotope, which is 23.99. So I'm through with my first isotope. And I add that to that same process for the second one. So percent abundance is 10 times its mass, 24.99, through with that isotope. And then I move to my last isotope. Percent abundance, 11.01. Mass, 25.99. Through with that isotope. So I've done all 3 isotopes. So I take all of that and divide it by 100. And when you're putting this in your calculator, you do need to use your parentheses. I had some student that couldn't figure out what they were doing wrong, but they weren't using parentheses. Remember, my answer is going to be 2 places past the decimal, so I should have gotten 24.31. My units, AMU, small AMU. And then I kind of think to myself, does this make sense? Is 24.31 somewhere in between my numbers that I was given, and it is. And it's closest to 23.99, which also makes sense since this percent abundance is a lot higher than the other 2. So that would be your correct answer on that one. So I'm going to do another example, and it's going to be on your practice, which is in your Google Classroom. So if you'll open that up. So this is your practice. It's in your Google Classroom. The chart is what you were doing yesterday. So it's good practice for the quiz. And then you're supposed to get the average atomic mass for each element that's in the chart. So those are what the yellow numbers are. Those are the correct answers, so you can practice them and then check your answer. I'm going to come down here and I'm going to do another example with number 9. So number 9 says three isotopes of argon occur in nature. I have argon 36, 38, and 40. Calculate the atomic mass of argon to 2 decimal places, giving the following relative atomic masses and abundance. So once again, I don't want to use those numbers if I don't have to, those mass numbers, and I don't, because down here I have the true atomic mass. So that's what I need to go with. So I had 3 isotopes. So my first one, 0.337 times 35.97. Then I go with my second one, 0.063 times 37.96. And then my last one, 99.6 times 39.96. And then I divide all of that by 100. So once again, I can kind of look, and if I look at it, because this one particular isotope, 39.96, was there almost 100% of the time, much, much higher than the other two, my answer should be pretty close to 39.96. That's just a little bit of number sense. And sure enough, when I put it in the calculator, I would have gotten 39.95, and my units are AMU. All right, so you have practice in your Google Classroom for that, and that is what we will quiz on. On Friday. And it'll just be 2 problems. So it's 100, a 50, or 0. They're pretty easy. It just takes a little practice getting them and doing them. So y'all got about 10 minutes or so, and y'all can practice on those.